Welcome to DriverDTrains. Thanks for stopping by. I'm your host, DriverD. Our conductor and brakeman, Scratchy-C, is back posting something new on GitHub. In my last video, we looked at how to assemble a WiTController to use with DCC-EX or JMRI to control our trains. In this video, we'll look further at the features of the WiTController and how to use it to control trains and consists, operate turnouts, and set routes on our layouts. Be sure to check this video's description for links to my other videos, as well as the various websites and products I mention here. Also, if you are enjoying the videos, please leave a comment and hit the like button. And if you haven't already, be sure to subscribe to the channel. Grab your clipboard and we'll see what's waiting on the track today. Using the WiTController to control our trains. Here are all the items on our checklist. First, we'll look at how to control our locomotives and consists with the WiTController and explore all its controls and menus. Then we'll look at how to use the WiTController to set turnouts and routes. Finally, we'll look at some additional settings we can configure in the WiTController code using the Arduino IDE. We've made our list and checked it twice, so let's get this train rolling. Using the WiTController to control our trains. Part 1. Controlling our locomotives with the WiTController. Here are all the deliveries on our manifest. Connecting to the command station. Now that we've assembled a WiTController, let's look at how to use it to control our trains. When we first turn on the WiTController, it will search for available Wi-Fi networks and ask us which one we want to connect to. This could be either our home Wi-Fi network or our DCC-EX command station running in access point mode. If we are connecting to our command station in access point mode, the WiTController will try to guess its password. This may not always work if our command station is running in access point mode with our station mode password, as I described in my video number 4D, Configuring DCC-EX Wi-Fi. We can configure the WiTController and enter the Wi-Fi network names and passwords for the various networks that we might want to connect to by editing the config_network.h sketch as I described in my last video. Otherwise, if we want to connect to a network that our WiTController doesn't have the password for, we can enter it manually using the rotary encoder, although it is a bit of a chore. Once the WiTController connects to our network, it will start searching for an available Y-throttle server. If it only finds one Y-throttle server, it will connect to that server automatically. If it finds more than one Y-throttle server, it will display a list and ask us to select which one we want to use by entering its number on the keypad. Depending on our connection to the Wi-Fi network, we may have to make a couple of attempts to connect to either the Wi-Fi network or the Y-throttle server before we are successful. Once we are successfully connected to the Y-throttle server, the WiTController will quickly cycle through a couple of different screens before landing on the home screen for throttle number 1, with a message indicating that no locomotive is selected. The WiTController can manage up to 6 independent throttles, each controlling its own locomotives and consists. When running trains, we can see the number of the throttle we are currently using in the upper left corner of the OLED display. We'll look at how to select another throttle as well as how to add and remove additional throttles in just a bit. Once we are on the WiTController's home screen, we can start using the keypad to access its menus and features. For basic navigation, there are 2 keys that we will use to navigate through the WiTController's menus and options: the star or asterisk key and the pound or hashtag key. We'll use the star or asterisk key to open the main menu and to cancel our selections and return to the home screen. We'll use the pound or hashtag key to confirm our selections, as well as to open lists of our locomotive roster entries, decoder functions, turnouts, and routes. Powering the track. Let's start by checking the track power. In the bottom left corner of the home screen, just above the star symbol, we will see the power icon. If the icon is white on black, that means that the track power for the main track is off. If the icon is black on a white square, that means that the track power is on. To cycle the track power, we can press the star key to open the main menu. We will see a list of 10 menu options. Number 8 is the track power, so we can press the 8 on the keypad to cycle the power to the main track. This will take us back to the home screen, and we will see that the power icon has changed to show the new state. Note that the WiTController will only cycle the power for the main track, not the programming track. To control the power for the programming track, we would need to create an automation in DCC-EX and configure it as a route. See Part 6 of my video number 4D, Configuring DCC-EX Wi-Fi, and my video series number 7 on how to create automations in DCC-EX, EX Rail for information on how to do this. Adding and dropping locomotives. Now that we've covered the preliminaries, let's look at how to control our locomotives. To do this, we first need to assign one or more locomotives to the throttle. We'll press the star key to open the main menu, and then press 1 to add a locomotive. We can add a locomotive manually by typing in its DCC address and pressing the pound or hashtag key. However, if we have added our locomotive roster to the myautomation.h sketch in DCC-EX, as I described in my video number 5D, using yThrottle and engine driver with JMRI and DCC-EX, or if we are using JMRI, we can press the pound or hashtag key to see a list of our locomotive roster entries. We can press the pound key again to cycle through any additional pages of roster entries until we find the locomotive we are looking for. We can then select the number listed next to the locomotive we want. Once we select a locomotive, either manually or from the roster, we will be taken back to the throttle home screen. We will see the DCC address of the locomotive we just selected in the upper left corner of the OLED display. We are now ready to control that locomotive. However, if we would like to control more than one locomotive, we can add additional locomotives to create a consist. We can again press the star key to open the main menu and press 1 to add another locomotive. Now, on the throttle home screen, we will see both of our locomotives' addresses listed at the top of the display. We can continue this process to add additional locomotives to our consist. Note that when building consists in this way, we should make sure that the throttle is set to the forward direction. Sometimes, however, the locomotives in our consists are not all facing in the same direction as our first locomotive. We can indicate which ones are facing in the opposite direction by pressing the star key to open the main menu, then pressing 9 to enter the extras menu, and then pressing 1 for Edit Consist. We can then select a locomotive from the list to indicate that it is facing in the opposite direction as our first locomotive. After we do this, we will return to the throttle home screen, and we will see that the address for the locomotive we just selected has a tick mark next to the number. This indicates that the locomotive is facing in the opposite direction as the lead locomotive. Note that the WiTController considers the first locomotive we selected to be the lead in the consist. We can drop a locomotive from the consist by pressing the star key to open the main menu and then pressing 2 to drop locomotives. We can then select from the list which locomotive we want to drop from the consist, or press the pound key to drop all locomotives. If we drop the lead locomotive in the consist, then the next one on the list will become the lead locomotive. If that locomotive has been facing in the opposite direction as the lead locomotive we dropped, then the next locomotive's direction will become the new forward direction for the consist, and the tick marks for all the locomotives will switch. And again, when we are ready to drop all our locomotives, we can press the star key to open the main menu, press 2 to drop locomotives, and then press the pound hashtag key to drop all locomotives. This will take us back to the WiTController home screen, indicating once again that no locomotive is selected. Finally, if we just want to run one locomotive at a time and don't want to run consists, we can turn on an option to replace our currently selected locomotive when we select a new one, rather than add the new one to the consist. This offers a shortcut so that we can select a new locomotive to control by itself without first having to drop the current locomotive. We can do this by pressing the star key to open the main menu, then pressing 9 to enter the extras menu, and then pressing 8 to toggle the One Loco setting. When this setting is on and we add a new locomotive, any previously active locomotives will be dropped. Then, if and when we want to run multiple locomotives together again, we can toggle off this setting the same way that we toggled it on, and we can once again add additional locomotives to run in a consist. Controlling locomotive speeds. Now that we have selected the locomotive or consist that we want to run, let's look at how to control its speed and direction. We can control the speed and direction of our locomotives by using the rotary encoder knob, the keypad, or the menu. The settings we will look at here are all the default settings, but we can change them in the WiTController software code. We'll look at how to do that in the third part of this video. By default, the WiTController software is configured so that if we turn the encoder knob anti- or counterclockwise, the speed will increase by 4 speed steps, up to a maximum of speed step 126. If we turn the encoder knob clockwise, the speed will decrease by 4 speed steps until we reach speed step 0 and our locomotive stops or comes to an idle. The current speed will show in large numbers in the middle of the OLED display. We can reverse the rotary encoder's behavior by defining the encoder rotation clockwise is increased speed configuration variable as true in the config_buttons.h sketch as I described in my last video. Now, turning the encoder knob clockwise will increase the locomotive speed, while turning the encoder knob anti- or counterclockwise will decrease the speed. Likewise, we can change the number of speed steps each turn of the decoder knob makes by changing the definition of the speed step configuration variable to the number of steps we desire, for example 1 in this case, as I also described in my last video. We can also use the encoder knob to set the locomotive speed to 0 at any time by pressing down on the encoder knob, which acts like a button. Depending on how our locomotive decoder momentum settings are configured, this will either cause our locomotives to stop immediately or else set them to idle and cause them to start slowing down to a stop. When the locomotive speed is 0, pressing on the encoder knob again will change the direction of the locomotive. So if the locomotive was previously moving forward, pressing the encoder button while the locomotive speed is 0 will change the locomotive's direction to reverse. Pressing the encoder button again will change the direction back to forward. In addition to using the rotary encoder knob, we can also use the keys on the keypad and functions in the menu to control the locomotive's speed and direction. By default, the 7 key on the keypad sets the locomotive direction to reverse, while the 9 key sets the direction to forward. We can also toggle the locomotive direction by pressing the star key to open the main menu, then pressing 3 to toggle direction of the locomotive. Note that we can change the locomotive's direction in this way without the speed being 0, which means that our locomotive may immediately change direction at a high rate of speed. So we'll want to use these controls with care. By default, the 8 key on the keypad activates the emergency stop function. While not configured by default, we can also assign functions to the keys on the keypad or other buttons to increase or decrease the speed of the locomotive or set the locomotive's speed to idle. In addition to directly controlling the speed, there are keypad and menu functions that affect how the encoder or other speed controls work. By default, keypad button 6 activates and cycles through the settings of the speed multiplier. Pressing the star key to open the main menu and then pressing the 4 key for X speed step does the same thing. The speed multiplier affects how many speed steps each single step speed adjustment makes. The default value is 2, which doubles the speed step amount each time we cycle the speed multiplier. We can see when the speed multiplier is active and its current multiplier setting with a fast forward icon just above the track power icon on the left side of the OLED display. For example, with the default speed step set to 4, if we activate the speed multiplier with the multiplier setting of 2, then the new speed step will be 4 times 2 or 8, and each turn of the encoder knob or press of a speed up or speed down button would change the throttle setting by 8 speed steps. If we activate the speed step multiplier a second time, then the multiplier would double again to 4. So each click on the encoder or press of a speed up or speed down button would change the throttle setting by 4 times 4 or 16 speed steps. A third press of the speed multiplier button or selection from the menu will deactivate the speed multiplier and return our throttle to its default setting. This will return us to the default speed step value of 4, or whatever we configure it to in the code. For example, 1 in my last video. Again, the settings that we just looked at are all the default values, but we can change these in the WiTController code using the Arduino IDE to set up our controller just the way we like. Activating locomotive functions. We can use the WiTController to activate any of our locomotive DCC decoder functions. By default, keypad keys 0 to 4 activate decoder functions F0 to F4, but we can assign additional functions to other keys on the keypad or to any optional buttons that we add to the WiTController. We can also select any of our decoder functions from the menu by pressing the star key to open the main menu, then pressing 0 for function. We can then either type the number of the decoder function we want to use and then press the pound key, or else press the pound key without typing anything else and open a list of all the available functions as defined in our locomotive roster. The functions are shown 10 at a time, and we can press the pound hashtag key to cycle through the screens. We then press the keypad number that corresponds to the number on the screen for the function we want to use. Note that when we activate a function, we will see the number of that function appear in a row near the top of the OLED display. Due to space limitations, only the last digit of each function is shown, but we can determine which functions are shown based on where the numbers appear from left to right on the display. Also, the next time we press star 0 pound to access the list of functions in the function menu, we will see all the active functions highlighted in the list. If we would like to more easily access the list of functions, we can configure the pound hashtag key to do that for us. We'll press the star key to open the main menu, then press 9 for extras, and then 0 for function key toggle. Now, in the bottom right corner of the OLED display, we will see the hashtag FN label. If we press the pound key several times, we will see the display cycle between showing the hashtag FN label and the hashtag keydefs label. Once we have the setting we want, hashtag FN in this case, we can press the star key twice to confirm the setting. Now, whenever we press the pound hashtag key, we will be taken directly to the list of functions, and specifically to the screen with the list of 10 that we last used. This is the quickest way to access all the decoder functions on the WiTController, and we can set a configuration variable in the code to make this the default setting. Regarding the operation of our locomotive's DCC decoder functions, most of these functions are latching functions, means that they are either on or off. Some, however, such as the horn, are momentary functions and are only active while we are pressing the key or button that activates them. WiTController generally determines which functions are latching and which are momentary based on the settings in our locomotive roster file and its communications with our DCC-EX command station or whatever other Y-throttle server, such as JMRI, that we are connected to. This applies when we activate a function from the keypad or from the list of functions accessed with the pound hashtag key. However, when we activate a function by entering the function number manually from the star 0 function menu, WiTController will force that function to be a latching function until we deactivate it. Also, if we add additional buttons to our WiTController, we can manually configure whether the buttons that operate DCC decoder functions behave like latching buttons or momentary buttons. Note that by default, except for the headlight, all the locomotive functions we use apply only to the lead locomotive in a consist. So, if we activate the bell, sound the horn, or turn on the ditch lights, only the lead locomotive will make those sounds or turn on those lights. However, there may be some other functions that we want all the locomotives to respond to, such as braking functions, momentum settings, or volume controls. We can configure these functions to apply to all locomotives in a consist, not just the lead locomotive, by setting some configuration variables in the WiTController code. We'll look at how to do that later in the video. together with the keys on the keypad, using the ## key function shortcut and adding additional buttons, we can easily access and control all of our locomotive's DCC decoder functions. Using multiple throttles. So far, we have only looked at using a single throttle to control one locomotive or consist at a time. However, the WiTController can manage up to 6 independent throttles, each controlling their own locomotive or consist. By default, the WiTController starts with 2 available throttles. We can select the next throttle by pressing the 5 key on the keypad. We can then add a locomotive to the throttle or build a consist just as we did before. Now we will see the number 2 in the upper left corner of the OLED display, indicating that we are using throttle number 2. Also, in the lower right corner, we will see the number 1, and below that, a number, 20 in this case, with a greater than or less than sign. This shows the locomotive or consist speed and direction on the indicated next available throttle. So for this example, the next available throttle is throttle number 1, and on throttle number 1, the locomotive speed is 20 in the forward direction. We can cycle through the available throttles by repeatedly pressing the 5 key on the keypad. We can add additional throttles by pressing the star key to open the main menu, then pressing 9 to enter the extras menu, and then pressing 4 for number throttles plus. We'll press the star key twice to confirm the setting. Now, when we press the 5 key again, we will be greeted with the throttle home screen for throttle number 3, and we can add another locomotive to control. And pressing 5 will cycle us through all the available throttles. We can delete the last throttle by pressing the star key to open the main menu, then pressing 9 to enter the extras menu, and then pressing 5 for number throttles minus. We'll press the star key twice to confirm the setting. Note that we can only delete the last throttle, not any intermediate ones. Also, when we delete a throttle, the WiTController does not change what the locomotives being controlled by that throttle were doing. So if our locomotive or consist is moving on the track, it will continue running at the same speed even after we delete the throttle that was controlling it, unless our command station steps in and tells it to do otherwise. Remember that we can always use the emergency stop button, 8 on the keypad by default, to stop all the locomotives on the track. The WiTController lets our command station know that it is still active by sending a regular heartbeat signal. Depending on how our command station is configured, if it does not receive the heartbeat signal within a specified amount of time, it may stop all the locomotives being controlled by the WiTController. If for some reason we want to stop sending the heartbeat signal, we can press the star key to open the main menu, press 9 for extras, and then press 3 for heartbeat toggle. An icon of a heart with a line through it will appear on the OLED display next to the track power icon. We can reactivate the heartbeat by repeating the sequence. Finally, we can save our currently selected locomotives on all our throttles by pressing the star key to open the main menu, then pressing 9 for extras, and then pressing 9 again for save locos. The next time we start up the WiTController, it will reopen our default number of throttles and reacquire the locomotives that we had selected on each throttle. If the command station still remembers which of those locomotives decoder functions were active, the WiTController will obtain that information as well. Note that the WiTController will only save and reacquire the locomotives for our default number of throttles. If we had opened additional throttles, the WiTController will not reopen and reacquire the locomotives for those. Disconnecting and shutting down. When we are done running our trains and ready to shut down our controller, we have several options. If we are powering our WiTController from the USB port, we can unplug the USB cable. If we are using a battery with a switch, we can turn it off. However, we can also turn off the WiTController and put it into sleep mode by pressing the star key to open the main menu, then pressing 9 to enter the extras menu, and then pressing 7 for off sleep. The WiTController will shut down. We can wake the WiTController again by pressing down on the rotary encoder knob button. We can also disconnect the WiTController from whatever Y-throttle server it is connected to by pressing the star key to open the main menu, then pressing 9 to enter the extras menu, then 6 to disconnect. This will disconnect the YT controller from the Y-throttle server and then attempt to reconnect to either the same or another server. If the YT controller is unable to connect to a Y-throttle server, we can press the encoder button to put it to sleep. Part 2. Setting turnouts and routes. In addition to using the YT controller to control our locomotives, we can also use it to control our turnouts or points and routes. The functionality is similar to selecting our locomotives, and we access these from the main menu by pressing the star key. From the main menu, we can select 5 to throw our turnouts or points to the diverging track, or 6 to close or line them for the straight track. As with selecting locomotives, we select the turnout we want to throw or close either by entering its number manually or by selecting it from the list of available turnouts we have created in either the myautomation.h sketch in DCC-EX or in the Panel Pro app in JMRI. Note that the YT controller does not show the state of the turnouts, so we'll have to look elsewhere for that. In my video number 8F, Add a Display to DCC-EX using an I2C multiplexer, I briefly showed DCC-EX displaying the layout's turnout status on an OLED screen. We can also use the YT controller to set our routes and run DCC-EX EX-Rail automations. To do this, we'll press the star key to open the main menu, then press 7 for route. We can then either manually enter the route or automation number that we want to set or run, or press the pound hashtag key for a list of available options received from DCC-EX or JMRI. Note that in order to dispatch a locomotive from our active throttle along a route, we may need to select the route from the list rather than entering its number manually. We have now covered all the features and menu options of the YT controller and seen how to use them. Let's take a moment to look at the YT controller code to see how we can configure these features to our own liking. Part 3. Customizing YT controller configuration. We can edit the YT controller code in the Arduino IDE to configure its features for our own needs and preferences. Wi-Fi network settings and some details about turnout and route preferences are in the config_network.h sketch, but we are not going to edit or look at those today. Just remember to enter your Wi-Fi network name and password as we discussed in the last video so that the YT controller can connect. Also, if we run or sometimes run our DCC-EX command station in access point mode, we can enter those name and password details as an alternative network. All of the rest of the edits we will be looking at today are made in the config_buttons.h sketch. If at any time we are unsure of what the original default values for the various settings were, we can refer to the config_buttons_example.h sketch. Rotary encoder, Part 1. The first group of settings affect how the rotary encoder works, and the first item is which direction turning the rotary encoder knob causes the speed to increase. Setting the encoder rotation clockwise is increased speed to true means that turning the knob clockwise increases the locomotive speed. The next two settings determine what happens when we push the rotary encoder button. The default action is to set the locomotive speed to 0 on the first press, then change the locomotive direction on all subsequent presses. However, we can change that action to perform any of the YT controller's other functions. We can see a list of the available actions in the actions.h sketch. So, for example, we could have the encoder button perform an emergency stop, activate the horn, switch to the next throttle, or any of several other options. Next, there are two debounce settings to smooth out the action of the encoder. The first, rotary encoder steps variable, is for smoothing out the rotation of the dial. I had to set the value to 4 for my encoders. Then there is a setting to add some debounce time to the button so we don't get multiple activations from a single press. And finally, there is a setting for using a bare EC11 encoder instead of a KY040 module. Numeric keypad. Next are the function assignments for the numeric keypad. Again, for each key, we can choose any of the actions from the actions.h sketch. We can also configure the name displayed for each key in the WiTController menu. Finally, if we prefer to use the #hashtag key to access our locomotive decoder functions, we can turn that on from the start by changing the hash shows functions instead of key defs variable to true. Number of throttles. Next, we can set the default number of throttles that we want to use when we turn on the WiTController. Note that this also affects how many throttles and locomotives the WiTController will restore on startup if we save them from the Extras menu. Rotary encoder Part 2. After this comes some additional settings for the rotary encoder, including the number of speed steps each turn of the encoder knob increases or decreases the throttle by, as well as the settings for the speed step multiplier. Note that there is also an additional speed step modifier that is intended to kick in when we turn the encoder knob rapidly, but due to some quirks in the code, the configuration variable here isn't actually used, and, at least on the rotary encoder I have, the setting never kicks in. DCC functions and consists. The next section allows us to specify which DCC decoder functions apply to all locomotives in a consist. By default, only the F0 headlight function applies to all the locomotives in a consist, but we can change that by defining consist function follow configuration variables for the functions we want to modify as consist all locos. User-defined commands. It is also possible for us to create user-defined custom commands. These must be formatted in the ythrottle protocol, the discussion of which is beyond the scope of this video. However, the provided example shows us how we can create a custom command to set a DCC-EX route or automation by defining our command as PRA2R followed by the number of the route or automation. This would allow us to trigger an automation or set a route with a single button press. Default function labels. We'll skip past the OLED hardware configuration, which we discussed in the last video, and the debugging section. In the next section, we can define the default labels for the locomotive DCC decoder functions, but we don't need to do this if we have set up our locomotive's information in our roster. Rotary encoder Part 3. We now come to the third batch of settings for the rotary encoder. These mostly relate to which pins on the ESP32 we are connecting the encoder to, which we will skip over. We'll also skip past the keypad hardware section, which we discussed in the last video. New additional optional buttons. If we decide to add additional buttons to our WiTController, we'll need to specify how many we want, what pins on the ESP32 they are connected to, and what we want them to do. There are two ways to do this, an old way and a new way. We'll look at the new way. First, we'll need to uncomment the line that says, Use new additional buttons format is true. Then we'll need to specify how many additional buttons we want. The maximum is 11. We can define all 11 additional buttons even if we don't plan to use them. Then, in the 4 lists that follow, we'll specify each button's action, whether it is latching, which only applies to buttons that operate locomotive decoder functions, what pin on the ESP32 it is connected to, or -1 if we are not using it, and whether it requires an external pull-up resistor. We can also configure our additional buttons to connect to an I2C GPIO expander. Throttle potentiometer. There is also a throttle pot section for configuring a potentiometer dial if we would prefer to use one of those instead of a rotary encoder knob for our throttle. Battery test. There is also a battery test section to show the battery percentage on the OLED display that we looked at in the last video. Note, however, that if we enable the battery test, we need to make sure that we are actually using a battery with a voltage divider to measure its output. Otherwise, the WiTController will shut down due to low battery unless we set the Use Battery Sleep at % to 0. Other configuration settings. There are a variety of additional WiTController settings that we can configure. These include 2 heartbeat settings, a setting to control how our rosters are sorted, and how we select which locomotive to release from a consist. We can also include a sketch that will show the WiTController menus in another language. German and Italian are included. We can define commands that the WiTController performs when it starts up, configure how it displays locomotive names, and whether it should always limit a throttle to just one locomotive and not allow any consists. We can also specify when our WiTController starts up whether it should or should not restore the locomotives we previously saved. Finally, we can change the font used by the WiTController on the OLED display and give our WiTController a custom name to show on the home screen. We have now looked at all the configuration settings for the WiTController. What's next? More controllers for DCC-EX. In future videos, we'll explore the WiTController some more, as well as look at a few other controller options for DCC-EX. Be sure to subscribe to the channel so you don't miss any upcoming videos, and check this video's description for links to my other videos, including my video series on assembling a DCC-EX command station and my series on using JMRI's Decoder Pro app to control our trains. We made it to the end of our list and delivered all our packages, so let's tie down and call it a day. I'm sure they'll have more waiting for us tomorrow. Until then, thanks for watching. Scratchy, what were you doing on GitHub? Updating the Scratchy-C catbot? What?
Welcome to the Scratchy-C catbot. How may I help you?
Oh boy. All aboard!